Hello everyone. Today we're going to talk about how to solve an absolute value equation. And an absolute value equation is essentially anything that has a variable within the absolute value symbols. Okay, so something like this. I'm going to switch to black, hold on. The absolute value of x equals 3. That would be an absolute value equation because the variable is within the absolute value symbols. Okay, now we can solve this one of two ways. We could solve this graphically, where we graph y equals the absolute value of x on one side, in y1 rather, graph y equals 3 in y2, and then find intersection points. We've done that many times, so I'm not really going to go through that. What I am going to spend quite a few minutes going through is how to solve these things algebraically. And what we need to think about when we're solving algebraically is the fact that absolute value makes whatever was inside positive. So if we're thinking about this example that I just gave you here, well, if the absolute value symbols were not there, then x could have been one of two things, right? X could have been 3, or negative x could have been 3, which means that x would have been negative 3. Okay, and if I take the absolute value of 3, I get 3. If I take the absolute value of negative 3, I get negative 3. And remember, this is kind of like the piecewise situation that we looked at yesterday with functions. If the function is negative, we put a negative value, a negative sign in front of it so that you have negative makes a positive. Okay, and so when we're removing absolute value symbols, we have to look at the two cases. The first case is that the expression inside was already positive, and so it's just exactly what the expression is. Right? So that's this case. The other possibility is that the original expression had a negative value. And in that case, we have to put a negative sign in front of it. And that's this case. So that if you take negative 3, you end up with a positive value. Okay? And so that's basically how we're going to solve these. Now, what we need to remember is that when we do that, when we remove these absolute value symbols, right, and essentially we're going to turn this into an either linear or quadratic equation in this course, we're changing the nature of the equation, and that can lead to extraneous roots. So we're going to have to then go and verify our roots in the original equation. Okay? All right, so let's take a look at the first one. We have the absolute value of x plus 5 equals 4x minus 1. Okay, so the first possibility is that the x plus 5 is positive. And if that's the case, then all we're going to have is that x plus 5 equals 4x minus 1. Okay, now here we just need to solve. So we're going to get, let's see, maybe I'll subtract 4x from both sides. And I'm going to have negative 3x plus 5 equals negative 1. And then subtract 5 from both sides. And I get negative 3x equals negative 6, which means x equals 2. So that's case 1. Case 2 is that the value inside the absolute value symbols was negative. If that's the case, then the absolute value function will put a negative symbol in front of the negative value to make it positive. And so what we would have is that negative x plus 5 equals 4x minus 1. Okay, because if the x plus 5 is already negative, and then I put a negative sign in front of it, that will make the whole thing positive, which is what the absolute value symbols do. And so we have to solve that as well. So here's case 1, here's case 2. So I'm just going to distribute the negative sign, and I'm going to get negative x minus 5 equals 4x minus 1. And I'm going to solve it very similarly to the last one. So I'll subtract 4x and I'm going to get negative 5x minus 5 equals negative 1, and then I'm going to add 5, and I get negative 5x equals 4, divide by negative 5 rather, and I get that x equals negative 4 over 5, or negative 0.8. I'm going to put it as a decimal actually, because that's going to help me when I verify. Okay, so these are my two solutions so far, but I still need to verify them. Okay, so verify. Okay, so my original equation, whoops, I don't know why I'm selecting all. Let's see how I undo that. Okay, maybe, there we go. All right, my original equation was the absolute value of x plus 5 equals the absolute, 4x rather, minus 1. And let's say I'm checking out x equals 2 first. So I'm going to check absolute value of 2 plus 5, and I'm also going to check 4 times 2 minus 1. And on the right side, on the left side, I'm going to get the absolute value of 7, which is 7. And on the left side, I'm going to get 8 minus 1. I keep mixing up left and right. On the right side, I'm going to get 8 minus 1, which is 7. And that means that left side equals right side. Okay, so this is a good and valid answer. If I verify x equals negative 0.8 into the same equation, maybe I'll try and get my lefts and rights not mixed up this time. Okay, so I'm going to plug into the left side negative 0.8 plus 5, and that gives me the absolute value of 4.2, which is 4.2. And on the right side, I'm going to plug in negative 0.8 times 4 minus 1, and that's negative 3.2 minus 1, which is negative 4.2. And in this case, the left side does not equal the right side, which means that this guy is extraneous. So we have to eliminate it. Okay, now if we wanted to look graphically, I didn't leave myself very much room here, but if we wanted to look graphically at what's going on, maybe I'll just try and squeeze it in here graphically. And of course you could graph these on a graphing calculator if you want. I'm just going to try and do it by hand because these are both linear. So for the second one, the second one is just a linear function. It's 4x minus 1, right? So that has a y-intercept of negative 1 and a slope of 4. So I'm just going to do a rough sketch because I just want to get a sense of what's going on here. So it's a pretty steep slope. So let's say it looks something like that. Okay, so that's like y equals 4x minus 1. Okay, now the other one is the absolute value of x plus 5. Now that normally, there's a y-intercept of 5 would look like, and a slope of 1, that normally would look like this, right? So you could see, okay, there's one intersection point, and that must be where x equals 2. And then remember that as soon as the linear function would go below 0, this is going to reflect upwards like that. So you can see how, in fact, there is only going to be one intersection point there. Okay? So that's how you would solve that graphically. And of course, you could enter that into a calculator. This second function here that I drew is y equals the absolute value of x plus 5. Okay? All right, let's look at another one. All right, solve. Absolute value of 4x plus 5 plus 9 equals 7. So in this case, make sure you isolate the absolute value first. So we're going to subtract 9 from both sides, and we're going to get the absolute value of 4x plus 5 equals negative 2. Okay, now we have a problem Because remember, an absolute value must make something positive. And so therefore we cannot have an absolute value equal a negative value. Okay, so this is going to have no solutions because an absolute value cannot be negative. Okay, and in fact, if you were to graph y equals 4x plus 5, or sorry, the absolute value rather of y equals 4x plus 5, here is a y-intercept of 5, and again, this is fairly steep. The slope is 4, so this is going to look something like this. And then remember, as soon as it hits the x-axis, instead of going below, it's going to bounce up and reflect. Okay, so this would be y equals the absolute value of 4x plus 5. And then if we were to graph y equals -2, that looks like this. Right? It's just a horizontal line at -2. These two graphs will never intersect. Okay, so you can have absolute value equations that do not have solutions. All right, okay, let's look at another one. And by the way, if you were to solve this by looking at the two cases where you make one of them positive and one of them negative, you could certainly do that like we did in the last situation. What you would find though is that both solutions that you get are in fact extraneous. Okay, so you could also solve it that way. All right, let's look at this next one. Okay, so we've got x squared minus 3x equals 2. So here we have two cases. Case 1 is that the expression within the absolute value symbols is positive. And in that case, x squared minus 3x is going to equal 2. Now, this is a quadratic equation, so we have to solve this. And to solve this, we're going to equate to 0. So we're going to get x squared minus 3x minus 2 equals 0. Now, if this is factorable, we would have two numbers that multiply to -2 and add to -3. And I don't believe that's possible because the only things that multiply to -2 are 1 and -2 or -1 and 2. And so the only way to solve for x here is to use the quadratic equation. Okay, so this doesn't factor. Or sorry, not the quadratic formula, the quadratic equation. Use the quadratic formula. Okay, so x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and that works out to be 3 plus or minus the square root of, let's see, this is going to be 9 and then plus 8, 17 over 2. Okay, and if we were to do this as a decimal, that's about, let's see, if I did that, I'm just doing this on my calculator right now, so 3 plus root 17, and then divide by 2, so that's about 3.6, and then 3 minus that is, and this is obviously rounded, divided by 2, -0.6. Okay, so these are rounded. Okay, so that's case 1. Case 2, I'm going to do this case below, is that the expression inside the absolute value symbols was negative. And if it's negative, what the absolute value function does is it puts a negative sign in front of that so that you have two negatives in a row, which makes the whole thing positive. So that would be negative x squared minus 3x equals 2. And then you're going to get negative x squared plus 3x equals 2. And I think what I'll do, again, this is quadratic, we got to solve it. I'm going to move everything on the left to the right so that the coefficient of x squared is positive. So I'll add x squared and subtract 3x plus x squared minus 3x on that side. And I'm going to end up with 0 equals x squared minus 3x plus 2. And that does factor because here we're looking for two things that multiply to 2 and add to negative 3. And so we have negative 2 and 1. So that's going to give us x equals 2 and 1. Okay, so we've got these and we've got these. And all four of those need to be verified. Okay, so now we have to do all of this verification. Okay, so let's just start with the first one, which is 3.6. Now, what you need to remember about the 3.6 and the negative 0.6 is that those are rounded values. And so when we plug them in, we're not going to get exact equality, but we're looking for something that's pretty close. And as long as it's pretty close, then that's good enough. Okay, so we're looking at the absolute value of x squared minus 3x equals 2. And so if we start with plugging in x equals 3.6, so I'm looking at the absolute value of 3.6 squared minus 3 times 3.6. And here I'm looking at 2. Okay. And this gives me, I'm just doing that on a calculator right now, 3.6 squared minus 3 times 3.6. This is the absolute value of 2.16, and this is 2. This is 2.16. Given that 3.6 was a rounded value, we can say that these are equal, that the left side equals the right side. Okay. If it had not been rounded, then those would not be equal. And in fact, if you want to get even closer, just keep extra decimal places on the 3.6, right? If I had rounded to the nearest thousandth, then this probably would have been a lot closer. Okay. If I test x equals negative 0.6, then I'm going the absolute value of negative 0.6 squared minus 3 times 0.6, and that is negative whoops. That is also 2.16, right? And of course the right side is 2. So this is 2.16. So again, we get left side equals right side. Okay, so these are both good. And then the last two, I'm running out of room here. Okay, so we'll try and squish this in. X equals 2. I'm testing the absolute value of 2 squared minus 3 times 2. And then the right side is 2. So this is going to be the absolute value of 4 minus 6, which is the absolute value of negative 2, which is 2. Okay, so left side equals right side. This one's good. And then I have very little room, but I'll try and squish it in. X equals 1. I'm testing the absolute value of 1 squared minus 3 times 1. And 1 minus 3 is also this side, of course, is 2. This is also the absolute value of negative 2, which is 2. Okay, so all four of these are correct, I should say. My grammar is not very good today. So the full answer is x equals, and in fact, we could now go back and use the exact values. 3 plus or minus the square root of 17 over 2, 2 and 1. right? I wouldn't suggest using the exact values for your verification because that's going to be really annoying to have to substitute in. And of course, if the question asks you to round, then certainly round. But once you know that it's an answer, you can certainly give the exact values because we've already found them right there. Okay, so this is the full answer. All right, one more question, and then we'll be done for today. Here's the last one. Okay, absolute value of x minus 5 equals x squared minus 8x minus 15. All right, so same strategy. We have to look at two cases. And the first case is that the expression inside the absolute value symbol is positive. And in that case, x minus 5 will equal x squared minus 8x plus 15. And so here we just need to equate to 0 because this is quadratic. So we're going to get 0 equals x squared. Oh, sorry, I should probably write down what I'm doing there, right? To get to 0, I am subtracting x from both sides and adding 5 to both sides. There we go. That's better. Okay, now let's write down the next line. So 0 equals x squared, and then this is going to be minus 9x plus 20. And this thankfully factors because we're looking for two things that multiply to 20 and add to negative 9, and that would be negative 4 and negative 5. So our solution from case 1, or solutions rather, are 4 and 5. Okay, of course these need to be verified. Case 2, the expression inside the absolute value symbols is negative. And in that case, we got to put a negative symbol in front of it, or a negative sign rather, in front of it, so that it makes it positive. So this is going to give us negative x minus 5 equals x squared minus 8x plus 15. So we will get negative x plus 5 equals x squared minus 8x plus 15. And again, I'm going to equate to 0. So I'll add x and subtract 5 this time. And I'm going to end up with 0 equals x squared minus 7x minus 10. And this also factors, which is quite nice because we're looking for two things that multiply to this is plus 10. Multiply to 10 and add to negative 7. And those two numbers are negative 2 and negative 5. Okay, so we get two solutions from here as well. We get x equals 2 and x equals 5. Okay, now you can see that there's an overlapping solution from the two cases. And so we only have to verify three things. We have to verify x equals 4, x equals 5, and x equals 2. Okay, and that's what we're going to do. Okay, so the original equation was the absolute value of x minus 5 equals x squared minus 8x plus 15. And I will maybe just start with x equals 4. So I'm going to plug in a 4, and I'm going to get the absolute value of 4 minus 5. And on the right side, I'll get 4 squared minus 8 times 4 plus 15. So on the left side, I get the absolute value of negative 1, which is 1. And on the right side, I get 16, and then 8 times 4 is minus 32, and then plus 15. And that works out to be 31 minus 32, which is negative 1. So in this case, we have an extraneous solution because the left side does not equal the right side. Okay, so this guy is extraneous. And so we have to cross it out. Okay, all right, let's try another one. X equals 5. Okay, so if I plug in an x equals 5, I'm going to get the absolute value of 5 minus 5 on the left, and on the right I'm going to get 5 squared minus 8 times 5 plus 15. And that gives me, on the left, 5 minus 5 is 0. So absolute value of 0 is 0. And on the right, I have 25 minus 40 plus 15. And 25 minus 40 plus 15 is also 0. So here we do get that the left side equals the right side. So x equals 5 rather is a valid solution. And then the last one I have to check is 2. So I'll do that as well. And when I plug in a 2, on the left I have the absolute value of 2 minus 5. And on the right I have 2 squared minus 8 times 2 plus 15. So on the left, the absolute value of 2 minus 5. So that's the absolute value of negative 3. And that is 3. And on the right side, I have 4 minus 16 plus 15. And that works out to be 19 minus 16 is 3. So we have that the left side equals the right side. So 2 is also valid. So the solutions are x equals 5 and 2. Okay? All right, so that is it for today. I will see you guys again